looking for? I told you, you're going to like this even better. Yes. All right, new notation for the definition of the derivative. N. And then we're going to look at the derivative of x to the n. You still have to know the other way. If it asks you to do it using the definition of the derivative, you can't just use this method, okay? All right, you know that the derivative of f of x equals the limit as h goes to 0 of f of x plus h minus f of x divided by h, right? Put over that. So we're going to use the h notation for the definition of the derivative to find g prime of x. Tell us g of x is square root of x. It's another form. There were two people that made calculus. One used delta x, and one used h. All right, so g prime of x. What are we going to do to figure that out? The limit as h goes to 0 Do you agree? Any ideas what to do to simplify it? Nope. It's an expression that would change the value of it. Oh, any ideas? Okay. I'll just tell you. I don't expect you to know what to do. I'll just tell you. We're going to multiply by something. But what? Yes, by the conjugate. What is the conjugate of this top term? We're going to get rid of some radicals. The square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x, that's 1, right? So we haven't changed the value of it, correct? We're just unrationalizing it, basically. Does that make sense? Okay. So we have the limit of h going to 0. What are we going to have to do? Distribute. So that's that, right? What's going to happen when we multiply that one and multiply those two? Because it's the conjugate. So do we really need to multiply those two and write it out? And then you agree. What's going to be in my denominator? And there's a reason that we're keeping the h separate. We didn't want to distribute it out. Anybody see why? These two x's will cancel. We're just going to have h in our numerator. Does that make sense? what? And so we're left with the limit as h goes to 0 of 1 over the square root of x plus h plus the square root of x. You with me still? So now what do we do? So insert 0 for h, and we have the square root of x plus the square root of x. Can we simplify that? How else could I write that so that I don't have a x to the what? Negative 1/2. Because the square root is x to the 1/2. And then I moved it up. Does that make sense? Okay. I want you to write it like that because our formula is going to be very helpful. Okay. All right. Okay. All right. So I want to find the derivative where x to the n, or find the derivative of x to the n where n is 1, 2, 3, and 4. Etc., etc. But we're just going to stop with 1, 2, 3, and 4. So to find the derivative, what do? Nope. The limit. Do you want to use delta x or h? H, okay. Of, what is our function? X plus h to the n. And then what? Mm-hmm. Then we're going to do it for n equals 1, 2, 3, and 4. So that's going to be what we're going to start with. If n equals 1, we're going to have the limit as h goes to 0. What is going to be our numerator? If that's a 1, you really don't need the parentheses. And then x to the 1 is just x, right? All over h. So x to the 1, what did you get for the derivative? Okay. For n equals 2, we would say the limit as h goes to 0. What would be our numerator? It'd be x plus h squared. So x squared plus 2 x h plus h minus x squared, right? X squareds cancel. You get the h's cancel. You have 2x plus h. What happens? Plug in 0, so the h goes away. So if you have x squared, what is the derivative? Go with me? Okay. Y'all see how that one works? I'm not writing it all out. We're trying to get to the answer a little bit. N equals 3. It equals the limit as h goes to 0. What would our numerator be? X cubed. Okay. Using Pascal's triangle. minus happens. Okay. Cancel one h in each term. So you have 3x squared plus 3xh plus h squared. What happens when you take the limit of that? So x cubed, the derivative is what? Do you agree? You'll see how that works? Okay. And then into equals 4. Say that again. What would our numerator be? X to the 4th. You agree? What happens? X to the 4th cancel. You take out an h in each one, and you're left with 4x cubed plus 6x squared h plus 4xh squared plus h cubed. You plug in 0, and you're left with 4x cubed. So x to the 4th equals, or whatever you take. That makes sense? You see a pattern? It is the derivative of x to the n. N times x to the n minus 1. It's valid for any real number of n, but not an irrational number like pi. I think so. It works on fractions. It works on whole numbers, negative numbers. It just doesn't work for or e. You can't have your exponent be e in this word. This rule is called the power rule. Let's say we have x to the 10th. What would be the derivative of x to the 10th? 10x to the 9th. Does that make sense? Whatever your power is, you bring it in front and you subtract 1 from here. Does that make sense? What would be the derivative of 10x to the 9th? 90. X to the 8th. Does that make sense? What would be the derivative of x to the 3 halves? Does that make sense? All right, going back to the one that we started with, x to the 1/2, the square root of x. 1/2 minus 1 is negative 1/2. And that's what we got. Does that make sense? So is this a lot quicker? If it says use the definition of the derivative and you use this, will you get it correct or wrong? Can you check your answer? Hopefully, you'll look at it and go, the derivative is this. And then when you work it out, you should get that. But if you don't show your work when it says use the definition of the derivative, it's going to be marked wrong. Does that make sense? Any questions on these?